The exception outlined in National Electrical Code Section 110.26 permits the doubling of working clearances, thereby eliminating the requirement for a second entrance or exit from the working space. This exception is contingent upon meeting specific conditions related to the depth, width, and height of the working space. Let's delve into each of these conditions to understand when and how this exception can be applied. Firstly, the depth of the working space must be doubled. The required depth of working space in front of electrical equipment is specified in Table 110.26A of the National Electrical Code, which varies based on the nominal voltage to ground and the conditions of the installation. Condition 1 exists where there are exposed live parts on one side and grounded parts on the other side of the working space, or where grounded parts are exposed on both sides. Condition 2 applies when there are exposed live parts on one side and insulated parts on the other side. Condition 3 is present where there are exposed live parts on both sides of the working space. For example, if you have equipment operating at 480 volts to ground, and condition 1 exists, the required depth of working space is 3 feet. To use the exception, you would double this depth to 6 feet. This increased depth provides a greater margin of safety for personnel working on the energized equipment. Secondly, the width of the working space must also be doubled. The code mandates in Section 110.26 SATO that the width of the working space must be the width of the equipment of 30 inches, whichever is greater. This width must be maintained from the floor or platform to the minimum height specified in Section 110.26, which addresses the height of the working space. To utilize the exception, this width requirement must be doubled. For example, if the equipment is 24 inches wide, the minimum required width of the working space is 30 inches. When doubling for the exception, the width must be a minimum of 60 inches. This increased width ensures that workers have adequate room to move and perform tasks safely. Thirdly, and perhaps most critically, the height of the working space must be doubled. Section 110.26 states that the minimum height of the working space must be 6.5 feet or the height of the equipment, whichever is greater. This height is measured from the grade, floor, or platform. The code further stipulates in 110.26 that the space equal to the width and depth required by 110.26 must be clear and extend from the grade, floor, or platform to the height required by 110.26.3. Now, considering the exception, the height of the working space must be doubled. This is where the constraint regarding the room height comes into play. If the height of the room is less than 13 feet, it becomes physically impossible to double the minimum required height of 6.5 feet. Consequently, the exception cannot be applied. To illustrate, suppose you have a room with a ceiling height of 12 feet. The minimum required height of the working space is 6.5 feet. However, to use the exception and eliminate the second entrance, you would need to double this height, resulting in a required working space height of 13 feet. Since the room's ceiling is only 12 feet high, you cannot meet the condition of doubling the height, and therefore the exception is not permissible. In summary, the exception in 110.26, which permits the doubling of working clearances to avoid needing a second entrance, requires that all three conditions be met. These conditions are the doubling of the depth, the doubling of the width, and the doubling of the height of the working space. Critically, if the height of the room is less than 13 feet, the height of the working space cannot be doubled, thus precluding the use of this exception. It's important to note that the National Electrical Code is intended to be a minimum safety standard. Always consult with qualified electrical professionals and local authorities to ensure full compliance with all applicable codes and regulations. Furthermore, remember that even when the exception can be applied, careful consideration must be given to the actual working conditions and the specific equipment involved. A larger working space, even beyond the double dimensions, may be necessary to provide a safe and efficient working environment. The purpose of these rules is to ensure the safety of qualified electrical workers while they are performing maintenance, troubleshooting, or repairs on energized electrical equipment. Ensuring adequate working clearances significantly reduces the risk of electrical shock, arc flash, and other potential hazards. Now, let's consider some specific scenarios to further illustrate the application of this exception. Scenario 1: a small electrical room houses a 480-volt panel. The room dimensions are 10 feet wide, 8 feet deep, and 10 feet high. The panel requires a working space depth of 3 feet per table 110.26 on condition 1. The panel is 2 feet wide, so the minimum working space width is 30 inches. The minimum working space height is 6.5 feet. To use the exception, the depth would need to be 6 feet, the width 60 inches, which is 5 feet, and the height 13 feet. Since the room is only 10 feet high, the height requirement cannot be met, and the exception cannot be used. A second entrance would be required. Scenario 2: a large industrial facility has a dedicated electrical room with ample space. The room is 20 feet wide, 15 feet deep, and 14 feet high. A 208-volt panel requires a working space depth of 3 feet per table 110.26 on condition 1. The panel is 3 feet wide, so the minimum working space width is 3 feet. The minimum working space height is 6.5 feet. To use the exception, the depth would need to be 6 feet, the width 6 feet, and the height 13 feet. All of these dimensions can be accommodated within the room. The exception can be used, and a second entrance is not required. Scenario 3: an outdoor electrical enclosure is installed on a concrete pad. The enclosure contains 480-volt equipment. The required working space depth is 4 feet per table 110.26 on condition 3. The enclosure is 4 feet wide, so the minimum working space width is 4 feet. The minimum working space height is 6.5 feet. The outdoor space is essentially unlimited in height. To use the exception, the depth would need to be 8 feet, the width 8 feet, and the height 13 feet. Since there are no height restrictions outdoors, the exception can be used, and a second entrance is not required. Another critical aspect to consider is the clear space around the electrical equipment. Section 110.26 of the National Electrical Code specifies that the working space required by 110.26 must be kept clear. This means that no obstructions, such as storage boxes, pipes, or other equipment, can be placed within the working space. This clear space extends from the floor to the required height of 6.5 feet, or higher if the equipment requires it. Maintaining a clear working space is crucial for safety, as it allows workers to move freely and safely while performing their tasks. Obstructions can create tripping hazards and impede access to the equipment, increasing the risk of accidents. Additionally, it's important to remember that the working space requirements apply even when the equipment is not energized. Electrical equipment should always be treated as if it is energized, and the proper working clearances should always be maintained. This is because equipment can become energized unexpectedly, and workers may need to access the equipment quickly in an emergency. The National Electrical Code provides additional guidance on specific types of electrical equipment and installations. For example, Article 408 covers switchboards and panel boards, providing detailed requirements for their installation and working clearances. Article 430 covers motors and motor circuits, including requirements for motor control centers and their associated working spaces. Consulting these articles can provide more specific guidance on working clearances for particular types of equipment. Furthermore, it's essential to understand the difference between working space and access space. Working space is the area around electrical equipment that is required for safe operation and maintenance. Access space is the area required to reach the equipment for installation, removal, or replacement. While the working space must be kept clear at all times, the access space may be temporarily obstructed during these specific activities. However, once the work is completed, the access space must be cleared to maintain the required working space. In addition to the National Electrical Code, other standards and regulations may apply to electrical installations depending on the location and type of facility. These may include state and local electrical codes, as well as standards from organizations such as the Occupational Safety and Health Administration or OSHA. It is crucial to consult all applicable codes and regulations to ensure full compliance and maintain a safe working environment. In conclusion, the exception in 110.26 of the National Electrical Code which allows for the doubling of working clearances to avoid a second entrance, is a valuable tool for electrical installations. However, it is essential to understand the specific conditions that must be met to utilize this exception. These conditions include doubling the depth, width, and height of the working space. If the height of the room is less than 13 feet, it is not possible to double the height of the working space, and therefore the exception cannot be applied. Always consult with qualified electrical professionals and local authorities to ensure compliance with all applicable codes and regulations, and to maintain a safe working environment for electrical workers. Understanding and adhering to these working clearance requirements is crucial for preventing electrical accidents and ensuring the safety of personnel working on or near energized electrical equipment. By carefully considering the dimensions of the working space and the specific requirements of the National Electrical Code, electrical installations can be designed and maintained to provide a safe and efficient working environment. Remember to always prioritize safety when working with electrical equipment and to follow all applicable codes and regulations. This includes wearing appropriate personal protective equipment or PPE, such as safety glasses, gloves, and insulated tools. Additionally, it's important to de-energize equipment whenever possible before performing any maintenance or repairs. When de-energizing equipment, it's crucial to follow proper lockout/tagout procedures to prevent accidental re-energization. This involves disconnecting the power source, locking the disconnect switch in the off position, and attaching a tag to the switch indicating that the equipment is being worked on. Only authorized personnel should be allowed to remove the lock and tag. Finally, it's important to stay up to date on the latest changes to the National Electrical Code and other applicable standards. The electrical industry is constantly evolving, and new technologies and safety practices are being developed all the time. By staying informed, you can ensure that you are always following the best practices and providing the safest possible working environment.